Good evening, everybody, and let me take this opportunity to welcome you all to the UCD Engineering Open Evening for 2018. And I'd also like to take this opportunity to welcome those that are online. So we have a number of people that are remotely watching the presentations this evening. So I'm going to begin by introducing myself. My name is John O'Sullivan. I'm an academic staff member in the School of Civil Engineering. So you're all very welcome to this event this evening. And I guess some of you might legitimately wonder why we're hosting an engineering event in the UCD School of Law. And the reason for that is that engineering over the last number of years, and this event in particular, has increased in popularity, and we're now no longer able to accommodate the scale of numbers that we get attending this event in our own engineering building. And even tonight now we have another room that's also operational for the presentations. So before we begin, I just want to take care of a little bit of housekeeping. And in the event of some unforeseen set of events, we have four exits in this room. We have one on my left, one on my right, and then we have two, one on the left and one on the right at the top of the room. So that's the exits that most of you would have come in this evening. I also might just ask people if they could switch their mobile phones to silent for the course of the presentations. Again, that will just help us in the course of switching over and so on. Okay, so I'm going to begin the presentation this evening with a little video clip.
We're born curious. Curious about the world around us. And curious to find out what we can become. We ask questions and seek answers, constantly challenging ourselves to think bigger, go further, learn more, to discover what's out there, what we can learn, and what we can give back. Because when we open our minds and let loose our imaginations, the scope of what we can achieve is limitless. And all you need to do to start that journey is take the first step. Find your degree at ucd.ie/CAO. UCD. Think bigger.
Okay, so that's an interesting presentation, and while it's not specifically associated with engineering, it does encapsulate many aspects of engineering. So we see idea generation, we see challenges, and we see the role of intuition, if you like, in addressing those challenges. So they're all very, very important features in our engineering programs, and we'll be touching on those. So I would ask people in the room, perhaps, the students particularly, to open your mind to an engineering program and ultimately to an engineering career. The order of proceedings for the presentations this evening are broken into four parts. So we have four presentations, each of about 15 minutes. The first one is going to be given by myself, and I'm going to be talking about engineering in general, engineering in UCD. I'm going to give some sort of a flavour of the structure of the engineering programs in UCD, and I'm going to try and convey to you the depth and scope of the engineering programs that we have on offer. The next presentation will be given by Ms. Leonie Phipps from the UCD Career Development Centre, and Leonie will talk to you about the sort of career opportunities that are available for graduates of our different engineering programmes. The last two presentations then are given by a current student and a recent graduate of engineering programmes in UCD. So the third presenter is going to be Lawrence Gall. He's an ME student in civil engineering, and he's going to try and convey to you a sense perhaps of what it's like being a student of an engineering programme in UCD. And the fourth speaker then is going to be Ellen Cahill, and Ellen is a recent graduate from the biomedical engineering programme, and she's pursuing studies now again in the school by conducting or undertaking a PhD, and she'll talk to you about that. At the very, very end of the proceedings then, all of the speakers will gather at the podium, and we'll have a questions and answers session that maybe will enable you to ask questions perhaps that weren't addressed in the core presentations. So I'm going to begin by giving a little bit of context about the School of Engineering in UCD. And firstly, it's a very large school, and it's the largest school in the country, about 50% larger than our nearest competitor or our nearest rival, if you like. And that allows or offers some advantages. It certainly assists us in delivering the range of degree programs that we have on offer. So at any given time, we might have 1,600 undergraduate students in the program. We might have an additional 500 students who are pursuing taught master's programs. And then we would have somewhere between 200 to 250 PhD students who are conducting research In addition to that, then, we would have we'd have postdoctoral researchers, and the PhD students and the postdoctoral researchers assist us in the delivery of some of our programs. The school is research intensive, and by that I mean academic staff in the school are heavily engaged in research, and that's reflected in the research profile of the school. So if we look back over the last 5 years, we would have generated perhaps in excess of 100 million euros. We would have in excess of 4,300 publications, and while that mightn't appear important, students pursuing engineering programs in UCD are being taught by academic staff who are experts and recognised experts in their field. So they have worked to develop the type of program that will enable you as graduates of those programs to do what you want in your engineering careers. I have another video clip that you might have seen before. This is a video clip that has been prepared by Engineers Ireland, and I'm just going to play this now.
Will you come with me?
Across bridges and railways.
To feel the Atlantic's wave power.
To brave new worlds. From the rudder to the engines.
To making monsters.
These things are there for me and you.
From purifying water with reverse osmosis.
To stopping cells dying.
From apoptosis.
Multiplayer.
Online.
Gaming. Clearing minds.
And saving lives.
These things are there for me and you.
Chartered engineers, bringing dreams to life for me and you.
So hopefully that video clip might have given you some sense of what an engineering career might be for you. And I have one other clip that I'm just going to play. It's more light-hearted. And again, I apologise if somebody has seen this previously.
I've been sitting here for nearly a minute without entertainment. Change the battery in the remote. The one on the left. The one on the left? Well, that's just spooky. Not really. I have the knack. The knack? For technology. My mom says I always have.
I'm worried about little Dilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
It's perfectly normal. Kids take things apart.
Ooh. The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical, and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer.
No!
There. Don't blame yourself.
Will it go away over time?
It might, but pray it doesn't. If an engineer loses the knack, the results can be devastating.
And in further news, you might want to get out those...
Thanks for filling in for our regular doctor on such short notice.
I was in the neighborhood.
So perhaps the students in this room have the knack. Perhaps they like using maths and applying scientific principles to solve or address everyday problems. Perhaps they have a natural aptitude for mathematics. Perhaps they like developing creative solutions to particular engineering problems. And perhaps they just haven't found the sort of program that would enable them to do so. So that's really what engineering, or encapsulates the essence of engineering in my view. So the next question one might ask is why I would choose to study engineering at UCD, as opposed to engineering at some other institution. And that's a very valid question. And the first thing I would say is that UCD is consistently ranked amongst the top 1% of universities in the world QS rankings. And if we look at the subject area rankings, again on the same QS, in the same QS rankings, we see that civil and structural engineering is ranked number 1 in Ireland. We see that mechanical engineering is ranked number 1 in Ireland. UCD chemical engineering is ranked number 1 in Ireland. UCD electrical and electronic engineering is ranked number 1 in Ireland. And UCD materials engineering is ranked number 1 in Ireland. So we offer a world-class engineering educational experience, and that's reflected in the range of awards that we have won for the programs that we offer, particularly in the course of the last 10 years when we were developing our suite of 5-year ME programs. Nationally, UCD offers the widest range of engineering degree options. And we don't ask students to make a choice as to which pathway they're going to follow until the beginning of year 2. So everybody gets an opportunity to be immersed in an engineering education for a year before they're obligated to start choosing their pathway. We have links with major employers, and we use these links to facilitate the 6 to 8 month professional work placement for those students that are engaged in the 5-year master's program. And that's something that's hugely beneficial for the students and also for the employers. And what we find from experience is that graduates of our programs then use the placement provider, the employer who offered them the placement, as their first graduate position. So those placements are paid placements for 6 to 8 months, depending on the discipline that you're involved in. All students have access to non-engineering modules through the UCD Horizon scheme. So all students can choose modules or subjects outside of their core engineering discipline. They can also choose subjects within that core engineering discipline, and that's a good thing. They can build capacity in certain areas, but perhaps some students might have an interest in pursuing a language that they started studying in second year or second level, and they want to continue that onward. So that can happen through the UCD Horizons module. All modules from philosophy to zoology can potentially be explored, timetable permitting, under the UCD Horizons scheme. All of our engineering programs are accredited by Engineers Ireland, who are the agents for the Washington Accord Agency. And that basically means that all of those degrees are transferable, so they're transportable. So a student who graduates with an engineering qualification from UCD can work in the US, can work in Canada, can work in Australia through that recognised accreditation. In addition to that, the chemical engineering degree is accredited by the Institute of Chemical Engineers in the UK, and our engineering and material science programme is accredited by the Institute of Materials, Minerals and Mining. So everything is professionally accredited, and that's very, very important when it comes to chartership and professional recognition of the degrees that are offered. So I made the point that nationally we have the broadest range of degree options, and they're summarised on this slide. So students can graduate with MEs in biomedical engineering, biosystems and food engineering, chemical and bioprocess engineering, civil, structural and environmental engineering, electrical energy engineering, electronic and computer engineering, energy systems engineering, engineering with business, mechanical engineering, materials science and engineering, structural engineering with architecture, and finally electronic engineering. So that suite of offerings is broader than is offered anywhere else nationally. The structure of the engineering programme is reflected in this slide. So all students enter into a common first year, and that common first year is accessed through the CAO code DN150. And the idea of that first year, the idea of the first year, or the curriculum in the first year, is that it builds or develops the fundamentals in mathematics and scientific principles that will enable students to apply those to engineering systems later on in their chosen discipline of study. In addition to the core offerings in first year, students can choose option modules, and they can choose from in-program electives. And they will serve to provide students perhaps with a flavour of the sort of course content that would be available to them if they were to pursue a particular discipline. At the end of year one, then, students must make a choice, and that choice is associated with the students choosing their particular pathway. So at the end of year one, students can choose one of 7 pathways, and those pathways are biomedical, chemical and bioprocess engineering, chemical with biochemical, civil, electrical/electronic, mechanical, or structural engineering with architecture. So there are the 7 pathways. Students then enter year 2 along that particular pathway, and then those subject areas are developed in years 2 and 3 of the curriculum. And at the end of year 3, then students have another choice to make. And that choice is whether they're going to pursue the BE degree, which is a 4-year degree, that was our traditional offering, or whether they're going to stay in the system and study for a further 2 years to graduate with the ME in engineering. And if students stay on in the full 5-year programme and study the ME, the full range of options that I alluded to a few moments ago are available to them. So how many points do I need? This is a question we're always asked, and people will know that points are purely a supply and demand issue. The more people that apply for a particular course, the higher the points are going to be. And as a consequence of that, the points last year or the points in previous years aren't a particularly good indicator of the points that we might have to achieve in this year coming. So last year's points, as an example, under the new CAO scoring system, the last points, if you like, for random entry were 498. And typically over the last number of years, engineering programs in UCD have hovered in around the 500, 510 mark. So that's just an indication of the sort of points requirement that may be expected, bearing in mind that points that are highlighted here aren't necessarily a great indication of what the points might be next year. To enter the engineering programs in UCD, we need 6 Leaving Cert subjects. So we need English, Irish, mathematics, and we must have a minimum of a H4 in that. We need 1 laboratory science subject with a minimum H6 award in that. And the laboratory science subjects that we consider are chemistry, biology and physics, but I should also mention there for UCD engineering programs, Phys Chem and agricultural science are also counted as laboratory science subjects. And students, obvious question that somebody might ask is, well, if I don't have physics or I don't have chemistry, but I have one of the other science subjects, am I going to be at a disadvantage? And if we look probably at the cohort of first-year students, the majority of those students will have done physics, a lesser number will have done chemistry, a smaller number again will have done both physics and chemistry, but there is always a significant cohort of students that have done neither physics nor chemistry. And really what it means is that those students then would probably have to work harder at those particular subjects in first year, but they're still very, very well positioned to progress from year 1 to year 2. The learning environment in a third level institution like UCD is very, very different to what it would be in a second level learning environment. And everything is primarily underpinned by lecture delivery in theatres of the type that we're in at the moment. And in those lectures then the theoretical fundamentals are explained to students, derivations are presented, and applications of those fundamental and scientific principles to engineering systems are explained. The lecture teaching is supported and augmented in many modules by laboratories, and laboratories provide students with an opportunity to get hands-on experience with measurement methods, taking readings, analysing data, interpreting data. So they would be what I would call the hard skills. And in addition to that, laboratory exercises also provide students with an opportunity to address some of the softer skills. And by softer skills, I'm talking about communication, and I'm talking about the ability to work individually and also in a team setting. In addition to that, then, some modules will have tutorial exercises that are timetabled. And they allow students or provide students with an opportunity to again apply the scientific and theoretical fundamentals to engineering problems in a supervised environment. So we would have demonstrators and tutors assisting students in their work in that area. And then we would also have design exercises and project work. And that's exercises and project works that would be done in groups. So I have a few minutes that I can sort of introduce or provide you with a very, very brief flavour of what the different engineering strands might be. Civil engineering is my own discipline. And if I look at a definition of civil engineering, I see the construction and maintenance of fixed structures. So that's a sort of a traditional view of civil engineering, and certainly construction and infrastructure features in civil engineering. But for me, civil engineering is much broader than that. And it also incorporates analysis of ground conditions through geotechnical engineering. It deals with water resources, so water treatment, wastewater treatment, the provision of water supply, flood prevention, hydrology, and everything else. So that in itself is a very broad area. We have a subsection of structural engineering. It deals with transportation systems, so the design of those systems, and also transportation planning, including public transport infrastructure. And in addition, then, management would feature. So if we think of an engineering career, it tends to involve management of projects. For civil engineering, there are large infrastructural projects. So the role of management and the role of finance also features in the curriculum. And what we would find is that while the majority of our students stay in a civil engineering setting, the skill sets that they get, not just in civil engineering, but across the full range of disciplines, makes students of engineering programs attractive for the financial services sector, for insurance, and so on. So the career opportunities are very, very broad. Structural engineering with architecture is another program that's offered through our school, and UCD is in the fortunate position that we offer degrees in civil engineering, and we also offer a degree in architecture. And the structural engineering with architecture is a combination of those two elements. So the idea of that program is that it would give structural engineers learning or create an environment in a way of interfacing with architecture. So somebody might ask, is this an architectural degree? And the answer to that is no. It's a structural engineering degree that's accredited by Engineers Ireland. It's not a backdoor into architecture, but it deals with the interface of structural engineering with architecture. And I have to be a little bit careful about what I say here. We would typically see architects as being sort of creative, perhaps more artistic than engineers, but engineers then being more pragmatic, perhaps more logical. And the idea of that program is that there's a bridging of the gap between the two specific disciplines. We would find that graduates of that program typically find career opportunities in structural engineering design offices, so the sort of consultancy setting, but we'd also see them having roles in project management and so on. Biomedical engineering then is a reasonably new strand of engineering, and it came about then from the increased collaboration of healthcare professionals with the engineering community. It occupies a space, I think it's fair to say, where traditional engineering methods are applied to solve problems in biology and in medicine with the overall advancement of the healthcare industry. And an example of that would be maybe pacemakers, implanted medical devices, neural stimulators, and so on. And it might surprise you to know that 13 of the top 15 worldwide medical device companies are currently located in Ireland. Ireland has a very, very strong reputation in orthopaedics, in the production of these medical devices, in the production of cardiovascular devices, in the production and development of implantable medical devices. And we would find then that the graduates of our biomedical engineering program would be obtaining graduate positions in those companies. In addition to that, then, Ireland also is the home for 250 or in excess of 250 worldwide health or med tech companies, and they also provide employment opportunities for our graduates. So mechanical engineering is what I would call one of the traditional engineering disciplines, albeit it has expanded in recent times to include aspects of biomedical engineering, aspects of energy systems engineering, and aspects of materials science. But at its core, it's concerned or focused on the design and the manufacture of components, devices, and systems. And if we think about components, devices, and systems, we're thinking about engineering systems, if you like, that might be exposed to adverse loadings. As a consequence of that, how they behave under those adverse loadings becomes important, so how the material behaves. And as a consequence then, there's a very strong correlation between mechanical engineering and material science. And that features also in the program. Energy systems engineering is associated with the engineering, the economics, the environmental considerations of engineering systems in both developing world countries and also in fully developed countries. And as a consequence of that, it has applications in a whole range of industries: the energy industry, the biomedical engineering industry, the aeronautical engineering, automotive and manufacturing engineering, the IT companies, and so on. Electrical and electronic engineering in UCD share some fundamentals. So in the first 2 years, those two programs are quite common. So there's not, in curriculum at least, there's not much of a difference between what the students of electrical engineering and those of electronic engineering will study. And it's only in the latter 2 years, particularly of the ME program, that differences or that students start focusing on a particular pathway, electrical or electronic engineering. And electrical engineering is concerned with the harnessing and distribution of electrical power into national grid systems. That's something that is very, very strong in a research way in UCD through the Energy Engineering Research Centre. Electronic engineering, on the other hand, then is concerned with the design of circuits and systems, so information and communications technologies, digital processing, the exchange of digital information, and so on. And again, there's very, very strong career opportunities for our graduates from these two programs as well. Chemical and bioprocess engineering might be described as a discipline that's fundamentally concerned with transformations. So typically the transformation of a raw material to a usable and useful commodity. So an example of that would be the transformation of crude oil to a petrochemical, or the transformation of a chemical or a chemical compound to a pharmaceutical. And in that space of pharmaceuticals and biopharmaceuticals, we see the landscape in Ireland has changed considerably over the last decade or 15 years. And now we see that Ireland is a base for a very, very significant number of worldwide pharmaceutical and biopharmaceutical operations. And again, these are areas where our graduates gain employment. There are opportunities in the second and third year of all of the programs to study abroad, and that might involve a semester or a full year in a university anywhere in the world. And we would have established relationships with universities from America all the way to Australia. So that's an opportunity that's available to students as well. All of the ME programs, as I mentioned earlier, have opportunities for professional work experience. This is a 6 to 8 month paid industrial placement in a discipline of your study. And here's an example of some of the providers of those placements that we currently have. Students are assisted in the competitive process of gaining these particular positions. So they're trained, if you like, on applications, on CV preparation. We run mock interviews, and it's a competitive process, but all students in recent years who were in the system gained employment, if you like, or gained positions through this process. It's important to note as well that companies do use the professional work placement or the internship as a recruitment tool, and we find then that a lot of the students who spend a placement with a particular company go back to that particular company as their first port of call after graduating. Who employs UCD engineering graduates? Well, the answer is everybody. In other words, engineering graduates are incredibly popular. They have a range of skill sets that lend themselves to positions in engineering companies, but also outside of engineering companies. And I'm thinking specifically there of the financial services sector, insurance, and so on. So just to close then, and I'm just going to finish up with a couple of points, maybe a couple of take-home messages. What I would say about UCD engineering is that we offer the widest ranges of degree courses, and we don't ask students to make a choice as to what pathway they're going to follow until the commencement of stage 2. All of the degrees that we offer are professionally accredited, and the courses are delivered by leading academic staff members in their particular field. There are study abroad or Erasmus opportunities in second and third year of the programs for students who wish to take them. All of our programs have excellent employment prospects. And in addition to that, it's worth mentioning then that over the last 10 or 15 years, the campus has changed considerably. The student centre has been developed. There's a 50-metre swimming pool, there's a theatre, there's debating chambers, and so on. So in addition then to the academic pursuits of students, there are ample opportunities for students to be engaged in a whole range of other activities through the different clubs and societies in the university. And then in addition to that then, there are a whole range of other supports, pastoral supports that are available to students who for one reason or another might be finding themselves in particular difficulties for some aspect of a particular programme. That's all I'm going to say for the moment, and I'm going to hand over now to Leonie, and we'll have an opportunity then for questions and answers at the end of the 4 presentations. Thank you.
Okay, hi everyone. So my name is Leonie Phipps and I am the Career and Skills Consultant from the Career Development Centre for the College of Engineering and Architecture. So today I'm going to briefly go through some careers in engineering and how to prepare for your future career. There'll be some kind of crossover between myself and John as well, so hopefully I'll get through it quickly enough. So what is an engineer? So an engineer is someone who turns ideas into reality, who solves problems and comes up with solutions, who creates designs from scratch and implements them, who uses their scientific knowledge and the theory that they've learned during their time here at UCD to actually solve real-world problems. So when I think of an engineer, I think of the following characteristics and traits. They're dreamers, innovators, researchers, problem solvers, inventors, and creators. So what does an engineer do in layman's terms? So an engineer might develop the next version of the iPad, a medical device that will help doctors treat an illness or save lives, and maybe they might do something around allowing water to be pumped to an undeveloped country, so designing systems, etc. There are lots of types of engineers, and I know John has got into kind of a lot of detail around that. So again, just to quickly go through it, so we have biomedical engineers, biosystems, civil, structural, environmental, electrical, energy, electronic, computer, energy systems, mechanical, chemical, aerospace, materials, and software systems. What do they mean? So I'm going to go through kind of the main ones and what they mean. So biomedical, so they're working with healthcare medical devices. They're designing devices from scratch. Civil, structural, so they're designing and constructing buildings, bridges, roads, etc. Electrical, electronic, so that's working with electricity and electronics. Energy, that's concerned with energy efficiency design. Mechanical, so that's the design of mechanical systems and devices. Okay, so qualified engineers are in demand in Ireland. So companies, I suppose, that kind of the main ones that would hire engineers, management consulting companies and professional bodies such as Accenture, your Deloitte, your EY, KPMG, etc. IT companies, so technology companies and startup companies as well, also hire engineers. Finance and banking companies would hire engineers as well. Fire and safety, technical sales, technical marketing, technical writing, and operations and logistics type companies as well. What kind of skills do engineers acquire through UCD and through working? So they acquire skills like analytical thinking, conceptual thinking, problem solving, planning, organizational, time management, IT skills, technical skills, flexibility, numeracy skills, research, and initiative skills as well. So transferable skill basically is a skill that you've acquired and used in one aspect of your life that can be applied to another area. So there's some kind of growth areas in engineering over the last couple of years. So this was taken from the National Skills Bulletin from last year. So there seems to be a demand for engineers within the pharmaceutical industry, the medical devices industry, and the manufacturing industry as well. There's actually a skills shortage within the following areas within engineering, so within process and design, quality control, or QA, which is basically testing, chemical engineering, electrical engineering, and mechanical engineering. What kind of employers in Ireland and globally hired engineers? So Ericsson, MSD, Abbott, Accenture, P&G, Glanbia, Arup, Ergrid, Deloitte, Amazon, Microsoft, Kerry Group, basically a lot of kind of technology and engineering companies. So the class of 2016, where are they now? So we actually did this survey back in September and we questioned engineering graduates. So 80% at that time were in full-time employment and 15% were actually in further study. I'm not quite sure what it's like now. We only do a survey once a year in September, October time. So the top employers for 2016 included Intel, Accenture, ESB, Arup, PM Group, Deloitte, Pfizer, BMS, and Boston Scientific. Okay, so again, just a quick recap on the sectors that employ engineers. So they work within the manufacturing industry, pharmaceutical, chemical, medical devices, electronic, computer and telecommunications, and within construction and civil. What kind of roles do these engineers have within these companies and sectors? So they're involved in design, research and development, production, implementation, and quality control. Typical job titles include biochemical engineer, biomedical engineer, biosystems engineer, civil engineer, electrical and electronic engineer, software engineer, mechanical engineer, and environmental engineer. So just some kind of quick tips on how to make the most of your time here in UCD as a student and how to prepare for your career. So, consider the following, if you decide to come here, and hopefully you will. What will employers be looking for when I finish? How will I demonstrate these attributes and skills? And how can I stand out from my classmates? Well, the Career Development Centre can actually help you with that. So it's all about making the most of your time here at UCD, and that's not just studying. So in your first year and second year, we encourage you to start doing the following. So join clubs, join societies. Employers love kind of volunteer work. They love when, students have been doing kind of teamwork and they've gotten involved in football teams, clubs, societies, etc. Get a part-time job, summer job, maybe do an internship. Start looking at kind of your values, your interests, what are you passionate about, join a professional body, and if you want to, learn a language. Your pre-final year, so attend employer events, attend career workshops. So career workshop talks you through how to do a CV, your interview skills, communication skills, presentation skills, etc. Find out about graduate recruitment and postgraduate opportunities, do an internship or work placement, and build and expand your network online and offline. Start talking to people. Final year, so make sure your CV is up to date. Come and book an appointment to the Career Development Centre. We'll go through that and guide you through that process. Refresh your interview techniques, analyse your transferable skills, attend graduate employment fairs and talks, and start applying for graduate roles or postgrad opportunities. What does the perfect applicant look like from an employer point of view? So employers are interested in, students and applicants who have, good academic achievement, who have those transferable skills, who have both good technical skills and communication and soft skills. Ideally, someone who has some sort of work experience, whether that's an internship, industry placement, or even a part-time summer job. Someone who understands the role or the company that they're actually applying for, and someone who's engaged with their community, so someone who does some volunteer work as well. That always goes down really well with employers. So we have a lot of resources and supports available in UCD for the students. Okay, so we have an extensive range of clubs and societies. We offer volunteering opportunities as well. We have 4 annual recruitment fairs per year, and we have 160 plus graduate employers that attend those. We have around 120 plus employer recruitment presentations and talks on campus every year, and we also provide academic internships as well. So what does the Career Development Centre offer students? So we have a jobs portal, which is available to all students who've registered here at UCD, and they can see the latest internship and graduate opportunities and entry-level positions as well. We have an events portal, so we advertise employer talks and we advertise skill sessions on the events portal as well. We have quick query meetings, so that basically is a one-on-one appointment with the student, and they can come and talk to us about anything career related. So we can review their CV, we can do interview preparation, we can do a mock interview, we can answer any questions related to kind of interviews and graduate recruitment. And we also have a lot of kind of online resources to help with CV and application and graduate recruitment. That's it. Thank you.
Good evening, welcome. My name is Larry Gall and I'm a final year civil engineering student here in UCD. So for the next couple of minutes I'm just going to talk you through what it's like for you to be in my shoes and for me when I was you before, what to expect and coming to UCD and what it's like to be well in particular for me a civil engineer. So first of all, I'm a Kilkenny man from the very, very southeast. I went to secondary school in New Ross in County Wexford. Like I said, I'm in my final year masters in civil engineering. I'm also a part-time farmer, and when I'm not farming, I'm also a UCD student ambassador. I'll tell you a bit about that later on. So you might ask, what do civil engineers do? Well, civil engineers plan, design, build and supervise a variety of construction projects. And these range from your road networks, your buildings and structures, your skyscrapers, your airports, runways, airport terminals, your tunnels, your bridges, but it also includes the new and emerging technologies. So previously, everyone taught engineers, they're kind of over there on their own, we do our own thing, we're all right. But it's become much more interdisciplinary. So we actually work with the electrical engineers, structural engineers, mechanical engineers on site. So for example, the new emerging technology includes self-healing concrete. So self-healing concrete, once cracked with micro cracks, can actually repair itself. And it also includes other areas such as the solar roads in the Netherlands. So at the moment they're trialling these out where they're trying to make roads out of solar panels. But this includes the work of like environmental engineers, structural engineers, electronical engineers. So we're all involved in one big interdisciplinary program. So you might ask, why civil engineering? Well, when I was very young, I was always interested in how things worked. Mum always gave out to me for breaking stuff, making stuff, all that. I was very interested in structures and how they built. At second level, I really enjoyed science, technology, DCG. I also really enjoyed programs such as megastructures, how it's made, grand designs. Three of my all-time heroes include Duncan Stewart from About the House, Dermot Bannon from Room to Improve, and also Kevin MacLeod from Grand Designs. So why UCD? So in sixth year, I had an opportunity to visit the campus, and I really enjoyed the campus. I liked the facilities, I liked the layout, and at the time, and still is, UCD was the top university in the country to do engineering. The omnibus, or common first year, was also very practical. So just in case in sixth year you might come on and say you want to be a mechanical engineer, but when you got a taste in first year and said, oh no, actually I want to do a civil engineer or electrical engineer, there was always that option as well. There's a very good mix of practical experience, both labs and field trips. And what I'll do later on, I'll just show you how we incorporate them into lectures. It also was UCD also was a very wide choice of civil engineering streams. So you can go into different areas like you've seen outside, civil, chemical, structural, environmental, all different areas. And also for the facilities. For example, the labs, the lectures, UCD Student Centre, UCD Student Bar, all great help. So next then, choosing your route, where to go and what to do. So I decided to go for the 5-year programme. Both programmes offer invaluable work experience. So the first 3 years were part of my BSc, my undergraduate, and then my last 2 years are part of my master's. It's important to know as well that the master's degree is accredited by Engineers Ireland. So after 5 years, you are a fully qualified, or you are a qualified engineer, but you can also work towards being chartership through Engineers Ireland. So I'll take you through my first to third year. So in my first year, like I said, it's common entry. So you do a variety of different modules, for example, physics, chemistry, algebra. I also do a few different modules, design modules such as design materials, mechanics, energy engineering. And this gives you just a flavour of what UCD has to offer in terms of the different streams. So at the end of first year then, I obviously chose to go into civil. And obviously you can see straight away there's a good change. You have more civil and structural based modules. For example, construction practice, statistics, soil mechanics, hydraulics. And then third year really is just to follow on from second year. So you can see soils 2, hydraulics 2, and also more in-depth modules, elasticity and plasticity. But most important in the bottom right-hand corner there is an opportunity to go on work placement. So, like I said earlier, you have a good mix of labs and fieldwork experience. So, just a few of our field trips. So, in second year, we did a module in construction materials. So, we learned about steel, concrete, and very other materials. So, while we were doing that, we learned about concrete, how to make it, how it's designed, different strengths. And then we went on a field trip to the Irish Cement producing factory in Drogheda in County Louth. And in a module in third year for construction practice, we were learning about project management, and we went to see the Kerry Foods plant in Naas while it was under construction as well. Placement is very important in getting your degree, and it also allows you to use what you learned in lectures and apply it to the real world. So because I'm a farmer and from a farming background, I had the pleasure of working on the Lakeland Dairies extension project. So Lakeland Dairies obviously process milk in County Cavan, and they were doing extension of that plant. So I was working with Malone O'Regan consultant engineers who who offer a job that's both on-site and in the office consultant, so it really suited me down to the ground. It was organised by the school, so like the UCD Career Development Centre helped us prepare workshops, CV sessions, mock interviews to get you prepared for applying for these jobs. So I was slightly different. At the end of third year, I didn't really know what I wanted to do or what to do next. A few of my friends wanted to go on and do masters. It was also a time where there was jobs starting to pick up again, and I really wasn't sure, but I decided, sure, what the hell, we'll go on placement again. So I decided to go a full-time on-site position because that's what I kind of enjoyed more. So from January to September 2016, I was working on the LinkedIn project. As you know, the LinkedIn project opened recently, a couple of months ago anyway, and that was a more on-site role, working with walls construction. You may remember the lunch on the skyscraper photo. Well, I think we did it better than them. So fourth year then I decided, after experience and going out in the real world, I decided no, I definitely want to do a Master's in Civil. I want to just broaden myself, get a 5-year degree, and hopefully further down the line get chartership. So when you go into the Master's programme, you have a lot more modules on offer. So you kind of choose what modules and what area really interests you, and what modules and what area you would like to go on further on down the line. So there's a few of my modules there: structural analysis, geotechnical engineering, case studies. And then as part of the Master's programme, you have again another opportunity to go on work placement. But this time I went completely very far away from home, and I decided to go to Canada. So from this time last year, from January to September, I had an opportunity to go to Canada to work with Ward and Burke Microtunneling, who are an Irish-owned company based in Galway, but they also have offices in the UK, in America, and like I said, also in Canada. And I was basically working on large-scale tunnels and concrete shafts that you see here in the photo. And it's basically improving water and wastewater pipelines that are either full or brand new sewer or water main lines. And the reason why I decided to go abroad is I just really wanted an opportunity to travel. I want to do something different. I want to go abroad. I wanted to get more experience. And while some of my colleagues stayed in Dublin or closer to home, some also went abroad as well, and it was a really great opportunity. Reasons why you do placement: obviously absolutely invaluable experience. You get to build relationship with your employer. You also have a very high amount of responsibility, and you get to apply college to the real world. Also, like I said, you get an opportunity to travel, and also going into your final year masters, it's nice to make some cash to go with you as well. As you can see, working in Canada was a 9-to-5 job, no time to do absolutely anything. The bottom, but in fairness, it was a really invaluable experience. You can see in the bottom left-hand corner, my 2 parents came over to visit halfway through, and I had a few friends coming over at various times as well. We also went abroad we travelled around Toronto, and then went to Vancouver and also up to Whistler. A really enjoyable time. Final year now, back to reality. A few of my modules here: water engineering, structural dynamics, bridge. Like I said, they're a bit more specific on what area you're into. And obviously, who can forget your thesis there the whole time hanging over the back of your head. So my thesis is actually based on the work I was doing in Canada, and my thesis title is "The Reduction in Skin Friction when Microtunneling through the Use of Lubrication." Now I know there's a few of you sitting there and thinking, Jesus. But trust me, it's really not that bad. When they're tunneling through the ground, the pipes are basically in contact with the soil, and using a soil-based lubricant, we're trying to reduce the skin friction, essentially. So in my spare time, when I'm not working, when I'm not in the library, when I'm on the UCD student bar, I do have a few hobbies as well. So I was on the UCD Engineering or NSOC committee. So UCD Engineering Society, NSOC, they organise trips away, field trips, days out. Companies and employers come in and give us talks. As you can see in the bottom right, they also organise stuff like the engineering ball. I also, as a farmer, I joined UCD AgSoc committee, or not committee, sorry, the society, because they organise important trips away, like, for example, national ploughing. Have to go, as a farmer, have to go. Like I said, I'm also a UCD student ambassador, so as you can see in the bottom left, we help out with stuff like open days, information events, organise talks to 6th class students, help out in career fairs and everything that way. And I also enjoy a game of five-a-side soccer. It's not really five-a-side soccer, to be honest, it's five-a-side messing, but we do it anyway. So the future, we can see from a lot of our college emails or targeted emails, there's always people offering us jobs or recruitment's fair on. And there is a huge demand at the moment for engineers, not just civil, but all types of engineers. So here's just a few newspaper articles: state infrastructure plans threatened by engineer shortage, huge demand for qualified engineers. So there really is a really big drive for engineering students. So I think it's fair to say, the engineering is bright. What's next for me? Very simple, 3 little pictures. I get my passport, I go on a plane, and I'm going back to Canada. I'm delighted to say I've been offered a full-time job as soon as I graduate to go back to Canada as well. Now, I don't want parents in the audience thinking like, oh Jesus, he's getting his degree and he's leaving. This really is my own personal decision. I could have easily stayed in Ireland because there is a lot of job opportunities here. But I just feel that I have a recognised degree and an accredited master's programme. I just feel like that the degree has given me the opportunity to go abroad and work in a variety of different projects all over the world. That's me. Thank you.
No, on this one here. A weird one. Hi guys. So I think I'm your last speaker for this evening. So after this, we're going to have a Q&A. So if you have any questions for us, you can fire ahead after this. So I'm going to talk to you a little bit about my experience in UCD. I've been here a little bit longer than Larry. I'm in my 9th year of education, to my parents' horror. But it's been all good, and I'm off their books, so they're happy enough. To give you a bit of my background, I'm from Castlebar in County Mayo, in the west of Ireland. 9 years in South Dublin has removed my accent. For my Leaving Cert, I really enjoyed maths, and as I'm sure quite a few of you do, and that may be why you're here. I did physics and chemistry in Leaving Cert, and coming into first year engineering, it did help, but there were plenty of people in my year who didn't do physics and chemistry. So if you're one of those individuals, don't worry, they start off from scratch and build you up to a pretty good standard in your first year. I did decide to go on to do biomedical engineering, and interestingly enough, I never chose to do biology in Leaving Cert. I didn't really like the teachers, so that was part of that. When I was in school, I was really interested in how things worked. I spent a bit more time in the shed with my dad fixing things than I did cleaning or cooking inside in the house with my mum. And I enjoyed solving problems and trying to get the answers to things. I went to an all-girls school. I was taught by a few nuns, and so our version of making things was sewing teddy bears, and I didn't get an opportunity to do any more engineering subjects. We didn't have applied maths or technical drawing or anything like that, but it really didn't make a difference once I came to UCD. So back then, 9 years ago, I was trying to decide where I was going to go and what I wanted to do, and I had sort of decided I wanted to do engineering, and I was looking at universities and trying to figure out where I would go. And there was 2 different things that I was looking at. I was looking at the academics and the extracurricular. So from an academic point of view, UCD is top engineering school in Ireland and has been recognised as such for a number of years. They have a really wide subject choice. And I had sort of decided that I wanted to go down the biomedical engineering route, and so UCD seemed like a good place to do that. And as Larry had spoken to you about, the work experience in the master's programme was really invaluable. At the time, other engineering programmes weren't doing it. Now more of them are. But because UCD has been doing it for quite a few years, they've built up really good reputations with industry. And so our students end up getting really good placements. And I'll talk about my placement a little bit more. But there's another aspect to it. This is going to be your life for a few years. Most of you for 4, some of you for 9. So you need to think about things outside of the library and your lecture theatres. And I was really interested in sailing, and UCD had a great sailing club, and that really had a big influence on my decision. So I think those aspects are sometimes things that people put secondary, but they're really big, important aspects in your life, and you do need to consider, if somewhere has a fantastic juggling club and you're a juggling fanatic, well, consider that when you're making your choice. They had good campus accommodation, and they were significantly further away from Mayo than NUI Galway, so that helped with my decision. So I started my engineering degree, and after my first year I went into biomedical engineering. So biomedical engineering is about improving human health through cross-disciplinary activities that integrate engineering sciences with biomedical sciences and clinical practices. So in my day-to-day life now as a PhD student in biomedical engineering, I work with electrical engineers, mechanical engineers, and we work with some surgeons, with physiotherapists, with nurses, and everything in between. And biomedical engineering is a really interdisciplinary subject. So you bring your knowledge and your background, but really to solve a lot of the problems we're solving, you need experts from all different areas. And that makes a really interesting team of individuals when you actually sit down to do the work that you end up doing. So the subjects in engineering, as you all probably know at this stage, in the first year it's very general. You come in general entry, you do all your basic subjects in physics and chemistry and maths, mechanics, and to bring you up to a certain standard, and then you start to choose in your second year a little bit more specialised modules that go into a bit more engineering depth, and if you choose biomedical engineering, you start going to medical sciences, so doing things like physiology and anatomy. In your third year, you start to stream a little bit more whether you want to go towards biomechanical, so the mechanical aspect, or bioelectrical, more electrical aspect of biomedical engineering. They're not recognised as two separate streams in UCD, but people tend to sort of, in their third year, do a little bit of both, and then if they go on to do a master's, sort of choose one of those areas, biomechanical or bioelectrical. But those decisions are quite a while down the line. So. In my third year, I went and I studied abroad in UC San Diego. So in second year, I applied to do the study abroad program, and UCD does have quite a good study abroad program. So they partner with universities all around the world, and UCD will take in so many students, and they'll send out so many students all across the way. So living in San Diego was pretty tough for a year. I had to carry a cardigan into lecture theatres with me because the AC was on so high. But I met a really, really interesting group of people from all over the world. And I am going on holidays with 7 of them in May from 3 different continents. So it's been it really added to my university experience. And while it wasn't quite here at UCD, it was really enriching experience to university. As part of my undergrad, I was involved in quite a few group projects. So Robo Rugby was a project where, a semester-long project, we had to design and build and program a robot to play a version of rugby. So it's sort of like Robot Wars. Have you ever seen that program on TV? It's like the South Dublin version of Robot Wars. So with my vast experience from Mayo Rugby, I brought that in and was on a team with 2 individuals, and so we had to build and program this, and it was a lot of fun. I did a project on ACL repair, so that was a group project where we looked at ACL injuries, which is really common in soccer players, and looking at how that impacted people's lives, what's currently done, what's the gold standard, and how that could potentially be improved. And I did a research project then on tissue engineering, looking at regenerating kidneys. Right. So after my undergraduate degree, I had 2 main options: to A, go and join the workforce, or B, go for further studies. So I know lots of people who went straight into engineering roles. Quite a lot of people at the end of 3 years decided, you know what, engineering degree has been great, but I don't want to work as an engineer. And having a degree which has given you a foundation in thinking analytically, puts you in a really strong position for jobs everywhere. I have lots of friends who did degrees in engineering. They're accountants, they're working as consultants in business firms across a huge range of different things. So while you may think about being an engineer, a degree in engineering gives you fundamental skills which are valued in a lot of different industries. And I guess being an indecisive individual, choosing engineering helped me with that because it left a lot of options open. It's not like I went to do nursing, and so if you do nursing, you become a nurse. If you do engineering, you don't necessarily become an engineer. You think you only have one choice to make. There's plenty of choices ahead of you, don't worry. So I decided to do further studies. I did the Masters in Engineering in UCD, and most of the people in my year actually went on to do that. So the Engineering Masters, Larry touched on it a little bit, and I think some of the other speakers did as well. So I'll give you a quick taste. There's a long list of modules that I did, and these were specifically biomedical engineering modules as part of the Masters. So for rehabilitation engineering, we spent, I think it was about a week in the National Rehabilitation Hospital in Dunleary. So the NRH deals with patients who've had severe traumatic experiences, such as spinal injuries or strokes. And we worked with the clinicians there, so surgeons, physiotherapists, occupational therapists, engineers, to look at what we could design and make to improve the rehabilitation process for these patients. And that was the first time I really got to see what impact the work I was doing could have on people. And I think a lot of jobs that you get from biomedical engineering, you aren't working directly with patients, but in the rehabilitation hospital, you could really see, we've designed this device, here is somebody who could use it, and you could see how much of an impact it was actually making on their daily lives. And these could be really, really simple things, from a device on their hand which allowed them to hold a pen and write, which, if for somebody who had limited communication potentially after a stroke, that's a massive life-changing device. And so I think rehabilitation engineering really opened my eyes to how much power you could have when you thought about these issues and these problems in the right way. Medical device design is another module I've highlighted there. I was teaching assistant for that this past year, and so that's a master's module where you're put into a group of 4 or 5 people and you're given a clinical needs statement. So the group I was working with this year, the clinical needs statement was a cohort of patients who had chronic wound chronic wounds. So a chronic wound is a wound that won't heal after 5 or 6 months. So people who have diabetes can get these on their feet, and other people get them from a variety of different things. So at the start of the semester, the group was given this needs statement, and then they have to go through a whole medical device design process. And this is a recognised process that's used all over the world. So you look at your patients, you look at the devices that are out there, you look from a business aspect, what financially makes sense, because you need to finance these devices. What's going to have the biggest impact? What can we make from a manufacturing point of view? And then later on in the semester, you go on to prototype these. So we prototyped the device using 3D printers we have in the lab, and then we tested them. So we tested them in some pig tissue that we had to see if the devices had an actual impact. So that was a really interesting module to do. As part of my master's, I did a work placement, and most people actually don't go abroad. Most people do stay in Ireland. So for all those mammies and daddies who are worried, I did go to Philadelphia in the US, and Larry did go to Canada, but most people do actually stay in Ireland. But again, this gives you hands-on experience and an opportunity to apply what you've been learning in university in industry. And once you go back to university, you have a little bit more perspective as to what you're learning in lecture theatres on day-to-day is applied. I was working on this device up here, top left, which is called the Molly device. So it was just a device for using syringes for patients who have to use them on a daily basis, and a more easy-to-use device. I was involved in the design of that device before it was put on market, and one of the designs led to a patent, which I got while I was with the company. So that was a really invaluable experience. They gave me so much responsibility and really an opportunity to learn a lot. I also got a job offer from that work placement, which was huge, knowing that I could go back into my final year of university, knowing that, okay, I've got my fallback offer is a fantastic job. So it took a lot of pressure off. I came back to UCD and did a thesis, and my thesis was on design and development of bulk metallic glass microneedles. That is complicated as Larry's title. So microneedles are really small, painless drug delivery devices, and so I was looking at those. I was really interested in this project and I saw a lot of potential in it. And so at the end of my master's, my thesis supervisor approached me and said, listen, I've got an opportunity to do a PhD. Would you like to continue your work into a PhD? And so I turned down the job offer and I decided to do a PhD in UCD. So after the master's, most people would join the workforce and go into an engineering role. But again, you've got all these options open to you. And I've outlined the black one because most people, that's what most people do. They do go into industry. And most of my friends got jobs in industry. And these are just some of the companies that you might have heard of, which some of my friends are still working at. As I said, I stayed on in UCD. I decided to do a PhD in engineering, and I'm looking at microneedles for drug delivery and sensing. So this picture sort of explains what I'm doing. You've got a rough outline. We use syringes on a daily basis for sensing and delivering, and I'm looking at using these microneedle patches, so a patch of tiny little needles used for delivery and sensing of drugs. So why did I do a PhD is a question I ask myself a lot of the time as well. I had a really good supervisor who I got on with very well. I had an interesting project. I wanted to learn more. I wanted to know more. And I really believed in the device I was making. I thought, we could potentially make something out of this. We could start a company out of this if this goes really well. And staying in academia gave me that opportunity to work 100% on something that I wanted to work on, rather than working for a company on whatever they wanted me to work on. They also say university is the best days of your life, so I squeezed in 9 years. And it also gave me a huge amount of flexibility. So flexibility is fantastic and terrible. I can come in at whatever time I want in the morning, which is the best part and definitely the worst part about what I do. But I've had a lot of opportunity to travel and do a huge range of different things. So I spent 7 months at the University of Notre Dame in the US, so some of the people from my research group, and they were really interested in the project I was working with, and I got to collaborate with some of the experts in their lab on this topic that I'm working on. There's my research group at the moment. These are some of the other engineering PhD students that I work with, and there's actually quite a few female engineers, so don't worry. As part of my PhD, I was asked to enter an innovation award competition in UCD, and I entered that last year and won first prize for the device I'm working on. And so they recognised the prospect of the device going on to form a company, and really, I guess, part of my reason for doing a PhD was to try and see this device through to making it to a commercial stage. It's not quite commercialised yet. It's a long road to go, but I've gotten a huge amount of support from UCD for it, and it's made it really interesting to know that people are interested in your work and it can have a big impact. I mentioned flexibility. I got involved in UCD, or decided to come to UCD for the sailing club was a big reason. I'm an avid sailor, and during my PhD that flexibility allowed me to not be in the lab all the time, and I ended up, my first 2 years I took quite a bit of time off and travelled around the world sailing on an Irish sailing team, and so I've really learned a huge amount, both inside and outside, the labs and the lecture theatres. What I'm going to do next, I don't really know, but I think I've got plenty of options, and a background in engineering really opens up a huge variety of options for you. So the one thing that I would say to you all, thinking about coming to UCD, thinking about doing engineering, I've mentioned that the academics is one aspect, and the other aspect is what else a university or a place has to offer. You're not just going to be studying here, you're going to be spending a lot of time here, your daily life, and so do think about the other aspects that are going to have an influence on that, and not just purely the academics, which is coming strange from somebody who's been in academics for 9 years, but yeah. Thank you.
Okay, thank you, Ellen. Okay, so what we've decided to do is we're going to split our resources or split our team. So we'll have a Q&A session in this room for everybody that's here now, and that will be hosted, if you like, by myself, by Ellen and by Laura, and then the other speakers that you will have heard are running the questions and answer session in the other room where we have another audience. One of the things I would just mention to you before we get into the Q&A session is that there will be opportunities for you to ask other questions from the academic staff members in the foyer at the conclusion of proceedings in this room. So not everybody will be leaving outside immediately, so there will be an opportunity to ask other questions. Okay, so what I'm going to do is I'm just going to throw the questions open to the floor and see does anybody have any pressing questions that they're looking to have answered. Yeah.
Hi, I was just wondering if you do bioengineering. I know ethics is quite a big part of biomedicine. I'm wondering, do you have any modules in ethics?
Yeah, that's a good point actually. So, well, ethics is very important, I would say, in all engineering disciplines, and the responsibility of engineers for design with respect to their societal obligations is something that features and permeates all activities in all modules. If we're specifically engaged in a particular piece of work, not just in biomedical engineering, but indeed in civil engineering or in any of the engineering disciplines, there are very, very strong procedures. There's an ethics office in UCD that is responsible for ensuring that the ethical obligations of all of our work is at the highest standard. Yeah.
No, it's just the English, Irish, unless you have an exemption, maths, the science subject, and then other recognised subjects. Another language isn't necessary. It's for some courses in UCD, but not for engineering.
Yeah, I think it used to be across the board, but I think it's been removed in some programs now. Yes?
Just the ME option. Do students just make that decision in third year, or when does that decision usually be made?
Yeah, that decision is made at the end of third year. And I think it's worth saying as well that, as with all master's programs, really in all institutions, there is an academic standard that's required to get into it. So in other words, if somebody has done so the way it would be it's something a GPA equivalent to a 2-1. And that's based on 30% of their year 2 performance and 70% of the year 3 performance. So that's the way GPAs are weighted in UCD. And that decision then and even if students don't reach exactly that GPA, there are opportunities where they can make a case for admission to the master's program on other grounds.
And when they're choosing in second year the different disciplines, is there any restrictions, like, biomedical, are there only a certain number of places where you may be?
Yeah, that's another, and that's the choice in first year. I think you're probably referring to. Yeah, first year. Yeah. So no, it's free. Yeah, it's a good question. So it's free choice. And I'm saying that now with a sort of a health warning. So we've never had a situation where a student hasn't been able to pursue a particular pathway that they would choose to pursue. But yeah, so in this example, if we take in 280 students, and all of those 280 students decided that they wanted to follow a pathway in mechanical engineering or civil engineering, that wouldn't be practical for health and safety reasons. So we have free choice. We never have had a situation where a student has been forced into an offering that isn't his or her first choice. But it is based on sort of health and safety, the health and safety situation with laboratory work and so on. So if I was to say that 10 years ago we had a lot of students choosing maybe the civil and the structural engineering. Now we have a lot of students that are choosing mechanical engineering and into the biomedical, some of the offshoots, if you like, of mechanical engineering. But they're still all accommodated currently with the numbers as the split is working out. Yes?
First year seems a very general year. How do people amass enough knowledge to make a decision on which choice to make?
Yeah, that's an interesting question. So Yeah, for sure. First year is designed, if you like, to build on the fundamentals that students will have from their second level education up to Leaving Cert. Now, in addition to those core modules, as I would call them, students can also choose some option modules and in-program electives. And those will provide students with an opportunity to at least gain a flavour of the sort of material that they would be covering in later years of programmes across the full range of disciplines. Now, in addition to that then, we also have suites of lunchtime seminars for students. So all of the disciplines are provided an opportunity to talk to the students once in the first semester of first year and again in the second semester of first year. And those talks then are aimed at providing students with enough information that will enable them to make an informed decision. So we would explain what civil engineering involves. We would have some of our current engineering students talking to the first year students. We would bring in graduates who are working in the particular engineering disciplines to talk to the first year students about what a career in that discipline involves, and so on. So all of the students have an opportunity to get exposure to what all of the disciplines entail in both semester 1 and in semester 2 of first year. So that, in combination, if you like, with the options and the in-program electives, we hope will enable students to make an informed decision. And that said, if students needed additional information, we're very approachable and quite happy to talk or assist students in the decisions that they're looking to make. Yeah, I'll come back. Yeah.
How much practical work is there related to lectures?
That's module specific. I'm going to use some of the modules that I would be coordinating to give you an example. So typically in engineering we have 12-week semesters, and in most modules I think it's fair to say we have 3 lectures a week. So over a 12-week semester we have 36 contact lecture hours. Now, in the modules that I would be involved with, I also run an additional 10 hours of tutorials in a semester and an additional 6 hours of laboratory work. But it varies across modules. There was a question further at the back.
Sorry, can you just explain more about the Horizon program?
Yeah, so Horizons is something that's unique to UCD. And in each of the semesters, students have sort of some credits, so maybe 5 ECTS or 5 credits to play with. So they have a set of core engineering modules that are associated with their particular engineering education. But in addition to that then, they're able to choose, well, they can choose another engineering option if they wish to do so, but they can also choose a module in any other discipline of their liking. And that could be from, as I said, zoology to psychology or physiology, or French or music or anything, once it's compatible with the particular timetable of the engineering student. And they pursue that module and they're examined in it in the same way as any student would be. So that's what the Horizons option seeks to do. So it provides students with opportunities to gain learning in subjects or areas outside of their core engineering discipline. And that runs all the way through the years. So what we would find actually is that some students might choose to take up Chinese as an example, or some students might choose the Horizons options to further develop the skills that they have in maybe French or German, or then we would find that some students choose the Horizons options to take up something entirely new. So that's not just for engineering, that's across the full university.
Another question here?
That's a loaded question. Well, I mean, what I would say to students who are sitting in the room here this evening, firstly, is that they obviously have an aptitude for maths and they have an aptitude for science and maybe the application of maths and science to the sort of systems that we consider. So I think engineering probably is not a program of study for the faint-hearted. It certainly is quite demanding. And typically, if I was to break down a week, I think it's fair to say, lectures will begin at 9 o'clock on most mornings, and there are 4 lecture slots up until lunchtime. And what we try and do is focus the mornings for lecture delivery, and then in the afternoons we would use that time for laboratories and for tutorials, typically. So I don't think there's any sort of fixed number of hours. When one looks at the timetable, you might see a very full timetable, but then when it comes to the delivery of laboratories, as an example, we have to alternate groups. So, there might be laboratories on every week, but a particular student might only be attending a laboratory every third or every fourth week. So there's free time like that. But certainly engineering programs, not just in UCD, but I think throughout the world, would be more time demanding. So I think there's a greater necessity in engineering programs to have contact time with the deliverers of the programs, perhaps more so than in maybe English or history, where there's more independent reading involved.
I think it's important as well that a lot of the learning in engineering is done in lectures, labs and tutorials, where a lot of other disciplines, or a lot of other areas of study, quite a lot of the learning is done by yourself in the library through reading books and assignments. And while there are still a lot of assignments, you do an awful lot of learning in a class environment or in a lab environment. And so the hours might appear on a timetable to be a lot more demanding, but I guess it depends how quickly you could write an English essay.
Yeah, and there's one point as well that I would say, and it's a bit of I think it's a false perception, and that perception is that engineering programs are incredibly difficult, and the attrition rates then are very, very high. So people bandy about these sort of numbers that only 50% of the students progress from year 1 to year 2. And that couldn't be further from the truth. If we look historically at the number of students that graduate in any given year, it's probably of the order of 90% of those students that would have come in year 1. And some of the attrition is associated with students making a decision or deciding that engineering perhaps isn't the course of study for them, and they just switch from one program to maybe something different. So we would have very, very high completion rates, I would say. And that's not taking away for the fact that some aspects of the engineering program, can be challenging for students. Yep.
If you go into your second year and decide you don't like your choice, is there any way to swap?
Yes, is the answer to that. But that doesn't mean that the transition is going to be particularly easy. So let's say you're in second year and you complete a semester, as an example. And in that semester then you have obviously, let's say, completed a suite of modules for mechanical engineering. And then let's say you want to decide maybe that you want to do civil engineering or some other discipline. So you have to then see what modules in that discipline that you have missed. So the transition isn't that straightforward. It might require you then, you could lose a semester depending on the modules that you have missed in a particular discipline. So we try and get students to be as satisfied as is possible with the decision they make at the end of year 1. But that doesn't mean to say, and we see it all of the time actually, and even in civil engineering, there's maybe more commonality between mechanical and civil engineering, so that switch would be easier than maybe civil to chemical engineering, as an example. So it really depends on the strand that you're switching from and to, and also depends then on where you are in the particular curriculum. But it is possible, and it does happen. So it's not good for anybody, the students or for us indeed, if we have students who are unhappy pursuing a pathway that isn't their first choice. So we try and accommodate them as best we can. Have we any? Yeah?
What infrastructure does the UCD School of Engineering have for the students to use?
For the civil engineering? Well, there's a full realm. I'll speak for civil engineering and structural engineering because it's something that I'm most familiar with. But all of the engineering schools have their own facilities to deliver their own laboratories and their own tutorials. So if I was to look at civil engineering, we have in the laboratory space, we would have obviously a hydraulics laboratory, we would have a heavy structures laboratory, we have a mechanics laboratory, we have water resources laboratory, and all of the different modules in those sort of spaces use those laboratories for the delivery of laboratory exercises. In addition to that then, we would have the 3D printing facilities in civil engineering. We would have capacity we have a timber laser cutter for developing sort of architectural type models. That would feature in some of the creativity and design modules. And all of the labs then are supported by technical resources. So there are technical staff that are assigned and responsible then for the ongoing maintenance of the equipment and of the laboratories themselves. And then in addition to that, then there are computer laboratories. And what we're actually finding are, so computer usage is well monitored in UCD. So in other words, if somebody logs on to a student computer anywhere in the campus, it's a recorded registration, if you like. But what's happening now is that increasing numbers of students are coming to UCD and to other third level institutions, for that matter, with their own computers. So the core computer facilities in the university are being increasingly less used. And that's something, so different schools will have different computer resources available to them. But most students then can log on, they can be network connected to the sort of softwares that are required in the particular engineering disciplines, and they get access to their own computer, to those sort of suites of software that were once the preserve, if you like, of the main core of student computers on campus. Yes? Yeah, that's probably something I should have mentioned. So if I go back, I don't know, it's a long time now, but if I go back 25 years when I was a student, and particularly maybe in the civil engineering program that I studied, the number of female students was incredibly low. I mean, it was sort of single figure stuff. And UCD, and there has been initiatives then over the last number of years to increase the penetration of female students into engineering programs, not just in UCD, but indeed nationally. And what we would find, and I think we're probably ahead of the game on this, we would probably, if I look at the first year cohort of students, so in other words the 280 students that have come in last September, I think 26 or 28% of them.
29, nearly 30% of students coming in for September this year were female students.
Okay, so it's increasing year on year.
That's the highest we've ever had.
Yeah. So it is changing, and we're very, very keen to continue that upward trend.
So I will say also, you do tend to see, once they choose at the end of first year, going into the different pathways, you do still see a certain split where some female students might go. The likes of biomedical engineering, chemical and bioprocess engineering is quite popular with female students. So that's just something to be aware of. But they are tending more and more now to split quite diversely, so you're seeing female students going into all disciplines.
And speaking as a female student of 9 years, I don't think it has made nothing but a positive impact, to be honest. I'm in the minority, which has helped me in a lot of aspects, but never such a minority that I feel like I'm one female in a group of 200 guys or anything like that. So it's never been an issue for me.
Yes?
Within the engineering school, what proportion of your staff have come to academia from industry?
That's probably a small percentage, but what I would say then is that we lever past graduates and people that are working in industry in the delivery of some of our modules. And in civil engineering, as an example, we would call on industry to deliver parts of modules. We have a module in fourth year which deals with case studies, and case studies are applications of designs in real worlds, and they're assessed by industry. So panels of industry come in and they assist in the teaching and the assessment of those exercises. But I think it's probably fair to say that that people who follow and teach on the programs and who have followed an academic career, they would have obviously done or completed perhaps a bachelor's or a master's degree. They would have gone on and done and completed a PhD. Some will have gone into an industry setting for a period of time, and then they come back into an academic environment to pursue research. That would be the typical sort of trajectory, I think, of a lot of staff. So they would have some exposure to industry, and even working in an academic environment doesn't preclude you having activities or associations with industrial partners through research or through a whole range of exercises, in fact. So I wouldn't like I'd like to sort of debunk the myth, perhaps, that we're kind of institutionalized in a place like this. We're engaging with industry in a whole range of areas, and they're advising the delivery of our programs. They're telling us what's deficient or what's new and what has to be taught to graduates that are emerging into workplaces in any given year. So we have we have very strong associations with industry across all of the disciplines. Yes? How do you get an opportunity to study abroad? It is, in essence. Now, so there's a process that has to be followed. And I think that process is best described as a module mapping exercise. So as an example, let's say you were a student in a semester of one of the engineering programs, and you decide in one of those semesters, or indeed for one of those years, second or third year, that you want to study in another institution. So that's perfectly permissible. And what has to sort of happen is, we have to be cognizant of the fact then that students come back from their semester or years abroad and then have to be immersed back into, the main UCD engineering program. So it's important that there is some consistency, I think, between the suite of modules that students will pursue while away and that the suite of modules that their colleagues and peers will be pursuing while here. So that involves a sort of a module mapping exercise. We don't want students to sort of miss 6 or 12 modules in UCD and then to have done 6 or 12 totally different modules. That makes the transition when they come back very, very difficult. So you're not restricted to any particular institution. We have relationships and established memorandums of understanding with a suite of institutions across the world where that module mapping has already been done. And they would typically be the receptors, if you like, or the receivers of a lot of our students. But that doesn't mean to say that a student can't do their own investigation and can decide that they want to spend a semester or a year in some other institution that no previous UCD student has gone into. But it just involves that module mapping exercise. So there's a process to ensure that the transition when the student returns to UCD isn't going to be too difficult.
And just to say, if you want to apply to the existing universities that UCD has a relationship with, there's a process that begins at the start of second year, and it's a bit like the CEO again for the Leaving Cert. It ranks based on your grades from first year. So if you are toying with the idea of studying abroad, the better your results are in first year, the more options you have available to you, and so the top students that apply for certain universities will get those. In saying that, pretty much everybody who I knew who wanted to go and study abroad in second year did get an opportunity to go somewhere, but it is based on your first year results. So no slacking.
Have we any other final question? Yeah? Yeah, well, okay. So if I was to look at engineering programs, Laura might be better versed in this, but typically students access the engineering programs in the UCD through the CAO system. So regardless of, so you have to have done the Leaving Cert and you have to have, I suppose, acquired the required number of points. There's no sort of easy transitions from other engineering courses into, latter years of the engineering programs in UCD. In other words, we have a cohort of students number-wise that we're sort of able to accommodate. That's full at the CAO. There isn't really capacity beyond that to take students. So while it happens occasionally, it wouldn't be, there's no sort of formalised routes for students coming from other backgrounds into latter years of an engineering program, year 2 or year 3 as an example. Typically it's by and large entered through the CAO system or through the A-level entry system.
Yeah, we don't actually currently have a proper route from the likes of FETAC level 5 or 6 courses. So typically if a student's going to want to come into UCD not straight from Leaving Cert, they still have to apply through the CAO with their results that they previously had, or they can wait till they're a mature student and apply that way, but it's still through the CAO. Now the other way students do it is if they want to, they can do kind of level 8 undergrad in another university, another institution, and then come to UCD to do a master's program with us then afterwards, and that's how they can kind of finish their degrees with us. But if you had a master's level, if that's what you're interested in, or it's through the CEO if you're coming from anything less than a level 8.
Yes?
Would most places be filled on the first round, or what was the competition?
Yeah, most places will be filled on the first round. I think I think that 498 points that I made reference to in my presentation, that was associated with random selection at that point. And then in the second round, it didn't go down any further than 498. There have been previous years where the first round might have been 510, and then it went down to 505. But we fill most of our places on the first round of the CAO. You can, of course. Yeah.
Career guidance in UCD. If your student is in sixth year and doesn't know, really like looking at science, looking at engineering, and would like to speak to somebody, is there anything in UCD, any service in UCD that provides that?
There wouldn't be a specific career guidance service, but if the student knows what area they're interested in, there's always academic staff members who will speak to students. I myself am in the marketing department and I meet with students all the time who are trying to make that decision. So it's not a formalised structure of career guidance, but people reach out to us all the time and we're more than willing to make time to meet with parents, students, either in person in UCD or through a Skype call, a phone call. Sometimes we go out to schools, we go to career events, things like that. So there's always opportunities to get in touch with us and be able to talk to us that way. And if you're interested in between two different programs, you can always meet with more than one staff member from a different department as well.
Okay, that seems like a good point, I think, to break up proceedings. So just thank you for your time. Thank you for your time. I hope you found the presentations and the questions and answering session informative. As I said, there still is an opportunity for those that have further questions to ask them out in the foyer. And I just then take this opportunity to wish you well in your travels home, wherever you've come from. So thank you.